Basically, today we're going to be doing section 6.5 and 6.7. We skipped section 6.6 on that, although geometry teachers have some objection to that one. But we're going to be still factoring trinomials. We're back. We're going to be doing some more practice with 6.5, factoring trinomials that have an a value that's not 1, not equal to 1. We're also going to be going over a couple other rules in factoring things out. So it's just more factoring practice. So this is going to be a fairly short lesson. You need your own piece of paper for your notes today that will go into your notebook. You know, there's no real notes today. There's a couple of things. We're going to talk a little bit about Pascal's triangle because it applies to here some of this reading. So it would be helpful if you open your books up to, first of all, to page... open up to page 276. I want to go over number 5 first. Number 5. And the reason for this is some of you got in trouble on the quiz because you really need, especially for ones that are negative, to refoil it. Let's see if we have... a problem like this. A lot of you on your quiz had the plus and the minus reversed. Now remember, we said that if we have a quadratic like this, a trinomial like this, that the answer in the end, one's going to be plus, one's going to be minus. But it's very important you get the right value in there. The right value in there, which is...
What number are you doing right now?
Actually, I'm not doing any number, but I'm giving you an idea. This is a 6.4 problem. This is the kind of problems you have in the test. But this was one that was missed a lot. Not because you guys factored okay, but when you did the box, you did the box correctly. But remember, a solution can be a plus or a minus. You could have factored out a positive, or you could factor out a negative. And many of you factored the wrong way. In other words, you made the positive a negative, you made the negative a positive. Even though it matched what your box said, it was not the solution because it didn't give you the original problem. All right, so if I'm going to do this, I do my diamond. Again, 1 times negative 16, I have negative 16. I have 6 in the middle. So I need to factor. And many of you forgot that it has to multiply to give you the top and add to give you the bottom. And so again, sometimes you get your plus and minus one reversed. And because the top is negative, I know that when I factor it, 1's positive and 1 is going to be negative. There, that's the only way I can get negative. So I can have 1 and negative 16. Negative 1 and positive 16. 2 and negative 8. Negative 2, positive 8, negative 4, positive 4. Which of these, remember, all of these will multiply out to give me negative 16. Which one will add to give me positive 6? Sam? Negative 2 and 8. So right here, negative 2 and 8. So I have negative 2 and 8. So that when I make my box here, this is review, but this is a very missed question. A lot of you missed a couple of questions like this on the quiz. So x squared and negative 16, positive 8x, negative 2x. Now, this side I might say, well, I can factor out a negative 8 on this one. And if I factor out a negative 8 on this side, I would have to factor out a positive 2 on that side. And then I'm going to get x and x. So I get x minus 8 and x plus 2. And I might say, did I do anything wrong there?
No.
No. hang on. And this is what I'm getting to. I didn't do anything wrong there. But now remember, our last step is really to FOIL. Now when they're both positive, I really don't have to worry about that. Or if they're both negative, I don't have to worry about that. But when one's positive and one's negative, you really have to refoil it to make sure you got the minus one the right and the positive one right. Hold on to your question. You might see the answer here. So when I FOIL this out, though, I get x squared minus 8x plus 2x minus 16, and that comes out to be x squared minus 6x minus 16. I didn't do anything wrong, but did I get the right solution? No. It must mean I should have done it the opposite way. I should have made positive 8 and negative 2, in which case I have x minus 2 and x plus 8. Like I said, I had a number of times where you guys had the right values, but you swapped the signs. You need to refoil it. Like I said, if they're both positive, you don't have to worry about it. If they're both negative, you don't have to worry about it because there's only one way to do it. But when you have a positive, the plus and the minus, the binomials where one's a plus and one's a minus, you really got to FOIL it again to make sure, did you get the signs right? Because the first time, did I do anything wrong here? No. We factored properly. You should also use this thing as your guide. Notice I had a positive 8, negative 2. That's a good guide of which one should be positive and which one should be negative. Okay, so that can give you a hint of which one it is. David, did I answer your question?
Yeah.
Sam, you had your hand up briefly.
But remember, go back to the problem, the equation. Remember, if that positive is a negative, then both of them equals positive, negative.
If this was in other words, if this is a positive and that's a negative, then they're both negative. Both binomials are negative. If they're both positive, they're both positive. But if you have, anytime you have a negative on the last term, whether this one's positive or negative, the answer is going to be a negative and a positive. Okay, so in other words, if the last term is positive, they're either going to be both negative or both positive. If the last term is negative, you're going to have one is one is the other. It's just a hint on how we have to solve the problem. All right, questions?
So hold on, we just messed up on it. So there's a negative at the end. There's going to be one positive, one negative. But
Yeah.
if there's two negatives, they're going to be one positive.
Negative and negative, it doesn't matter. Because it just means that, in other words, if this was negative 6, this would have come out negative 8 and positive 2. We would have the other, the signs would be reversed. But you still have the same, remember, it would have been this would have been the factor, negative 8 and negative 2. And then it would have been the way we did it the first time. This is the thing here, which one of this is. This tells you whether it's going to be it's both a positive, both negative. In other words, remember I gave you a chart, right? If you have positive and positive, you're going to have positive and positive. If you have negative and positive, you're going to have negative and negative. If you have positive and negative or negative and negative, it's going to be a plus and minus. Remember, we put that, well, you need to get the notes from last time. Well, if the middle term is a plus or a minus, but the last term is a minus, it'll still come out the same way, a plus and a minus. It's just, this is the pattern. You need to get the notes from your classmates from last time. That was a page in there. Or get it off Communicado. I think it's attached to the Communicado assignment. All right? So, let's continue to binomial expansion. So, there's going to be some more practice with section 6.5 on doing those ones. But we're going to do some notes here on page 6.7. Page 6.7. And actually, so turn to page 283, please. Everybody turn to page 283. 283.
This is another example.
No, this is...
So it'll be right
This,
now,
you're going to write these things down in your notes. Down in your notes. So, basically, this is what we've been talking about all along. But the steps to go through. I mean, these are those same steps we've had on there. Number one, always look first for a common factor. In other words, can I take a 2 out? Can I take an x out? Can I take a 5x out? All right? Look for those things that are taken out. Eurissa, instead of writing in the book, could you put stuff on a piece of paper? Always look first for a common factor. It's there. There's a little brown box there that we're getting this from. There in section 6-7, that little brown box. Number 2, let's say they letter B. Then you want to look at the number of terms. There are terms, like if you have a trinomial, x squared plus 2x plus 10. That has 3 terms.
What is it? Always first.
Always look first for a common factor. So the first thing you're going to do, 2 terms. If there are 2 terms, determine whether you have the difference of squares. In other words, that'd be something like this: 4x squared minus 9y squared. That's the difference of squares. And remember, that solution is something plus something minus. Now, that's one of our special cases. Difference of squares. But this is an example of what one of those would look like. Difference of squares. Three terms. All right, if we have 3 terms, binomial. So first of all, whether the trinomial is a square of a binomial. That's the first thing. Like if we have x plus y squared would be x squared plus 2xy plus y squared. Remember, it's this squared, that squared, but if I multiply the 2 numbers together and double it, do I get that middle term? If we had something like x plus 2 squared, it would be x squared. Actually, let's do 3 because it looks a little different. X plus 3 squared. So it looked like that. Notice the ends are squared, but if I multiply the square root of each and multiply by 2, 3x times 2 gives me 6x. That's what they're talking about for that part. Is it that? In other words, when we look at this, do we get that? It could be x minus y as well. Otherwise, If not, test the factors of the terms. That would be your diamond and box. In other words, this. In other words, if it isn't that special case, which most won't be that special case, you're going to use your diamond box. What? If not. If not, in other words, if it's not this, test the factors of the terms. We do diamond box.
Why did you draw a box runner at triangle?
Because.
To remind you, because this is how we usually draw it. We draw our diamond box this way. The reason we don't, I mean, technically the diamond would be something. That's what I mean by the diamond box. We don't usually draw the diamond around it. Just a waste of time. Alright. Now, and they have that fourth one. If there's four terms, which is not something we are doing right now, four terms we would factor by grouping. We're not doing factoring by grouping as part of this course. The third thing factor completely. In other words, if you end up with an answer that could still be factored, we've done a couple of those. If you can still, you got to look at the answers. Could I still factor this? Maybe it's still the difference of a square, that sort of thing. Could I still factor some more?
So factoring is like kind of like simplifying?
It's what we've been doing for the last 3 days.
Yeah, I know, but
It's factoring. It's not simplifying. It's factoring. It's not kind of like simplifying. It's factoring. Shh. Sam. Simplifying is something different. This is factoring. All right. So, they have a number of examples in there. These are all things we've already been doing. This was the things we have in our other notes, those 5 steps. You might want to add to this, at the end, you want to FOIL again, just to make sure you have the right factors. FOIL it back to its original value. Remember, we're dealing basically with trinomials here on that. You, chair out. Now, I'm going to talk a little bit about binomial expansion. Page 285. And then we'll start our classwork. You guys should be able to get your classwork and maybe a good chunk of your homework done and give you time to work on your test corrections and your corrections on your quizzes. Remember, those quiz and test corrections count a lot of points because those points go into the test section. Quizzes and tests go in the same category. They count a lot more than other assignments. So those points you get back, 10 points get back on a test could count as much as like a 40-point homework assignment. Just because it's weighted. Tests count a lot more than homework can. Shh. All right, binomial expansion here. All right, we use the distributive property. And we're talking about things if you had something like this. X plus 3 cubed. It's very hard to deal with that because we really haven't learned a method for that. So what you would do is you distribute it. I mean, this is the same as if we had 3 cubed actually means 3 times 3 times 3. If I have x plus 3 cubed, it's going to be x plus 3 times x plus 3 times x plus 3. Which means if we took the first two and FOILed them, and FOIL it, I would get x squared plus 3x plus 3x plus 9 times x plus 3, which comes out to be x squared plus 6x plus 9. So now all I would have to do is multiply that through again. And for something like this, you could use the box method. Shh. We have x and plus 3. We stop talking. Stop throwing things. Pay attention. Or we could have used this method that we learned. Remember, we have two different ways to really do this. You could do a FOIL type thing, but it's a little harder on that. But in either case, regardless of which of those two methods that you use, you're going to end up at the end. Basically, you're going to have an x squared plus 4x squared plus 4x plus 2x squared plus 8x plus 8, because basically what they did was FOILed it, multiplied everything through by the x, multiplied everything by the 3. How did they get an 8? Oh, because I used 3. So I need to do, because they used a 2, I used 3. So we end up with x cubed, 6x squared, 9x. I end up with 3x squared, 18x, 27. So this is going to give me x cubed plus 9x squared plus 27x plus 27. So notice I did that a couple of ways. Now, for ones that are just kind of like this, where you have an a and a b factor, a and a b factor, there's actually an easy way to do this. There's an easy way to do this.
Can't you take out a 3x from 6x squared and 18x?
What are you talking about?
The one in the middle.
What are we doing? 3 times 6x is 18x. Now, we're not factoring, we're multiplying here. All right? So, when you're faced with things like this, these binomial expansions, this is what you do. Shh. But you notice there's kind of a pattern to this. It's kind of a pattern. Maybe we need more time to get this copy down. So, notice there's a pattern here. Yes? Now, anything to the 0 power is what? 1. Anything to the 0 power is 1, except for squared plus let's look at this. I have x cubed. This is the a value. This would be the b value. Well, x cubed. What's 3 cubed? Is 27. 3 times 3 times 3 is 27. Now remember, this value is supposed to be 3a squared b. This is 3ab squared. First of all, this is 1x. So notice I get 1x squared, which is x squared. 3 times the b value of 3 is 9. Here, 3 times 1 would give me just x. Basically, 3 times x gives me x. B squared is 9. 3 times 9 is 27x. In other words, these values are matching it out. Since this is a squared, 3x squared, 3 times x squared times 3 would give me 9. 3 times x times 3 squared gives me 27. It's this, so this came out to be the right pattern. We get to the next one, the next layer. I'll switch colors. I get a to the 4th, b to the 4th. They're going to be at the ends. Plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4th. Notice our progression letters. We went from an a to the 4th and no b to an a cubed and a b to a squared, a b cubed to b to the 4th and no a. Numbers have a pattern though. We're going to talk about the numbers, but I think it's kind of where you get the letters. We're going to get to the pattern. Don't worry about. As far as the numbers follow a pattern too. But you can see when we have something to the 4th, notice I start with the first variable to the 4th, went down 1, we added a b. Went down 1, added a b squared. When 1 goes down, the other goes up. Now, think of this one as being a to the 4th, b to the 0. Our b to the 0 is 1. 1. Anything to the 0 power is 1. So here, without even looking, I know this one has just the letter part, a to the 5th is going to be a to the 4th b plus something a cubed b squared plus something a squared b cubed plus something a b to the 4th plus b to the 5th. The pattern of the numbers is something called Pascal's triangle. These are all the numbers we saw before. Remember, 1, a plus b, a squared plus 2ab plus b squared, a squared plus 3a squared b plus 3ab squared plus b cubed, and so on. And so on. But how do I get that? And I'll come back to this one, but I have a little animation for you. See how this pattern goes? These are where the numbers come from. So when we come up here, notice 1. Well, 1 plus 0 is 1. 1 plus 0 is 1. 1 plus, and at the end is always the 1. So we have 1. 1 plus 1 is 2. Here, I have another 1, but 1 plus 2 is 3. 1 plus 2 is 3. And we have 1s at the end. Notice there's always a 1 at the end. 1 plus 3 would be, so we'd have a 1. What would the next level be? 6. 15. And 1 like b would be a plus b to the 6th power, which would give me an a to the 6th, 6a to the 5th, b, and so on down to always have a pattern. So say we have this a plus b to the 6th. We would start with, and I'm not going to worry about the number part. We're just going to deal with the letter part. A to the 6th. Then a to the 5th, b to the 1st. Notice it's always adding up to 6. The exponent should always add up to 6 if it's the 6th power, if it was to the 4th power. If I come back up here, notice for the first, second, 1 plus 1, 2. The degree of each term is always going to be 6. Over here, the degree I get a to the 4th, b squared. A cubed, b cubed. A squared, b to the 4th, a, b to the 5th, b to the 6th. Since you're taking it to the 6th power, the degree, you add up all the variables. 6, 6, 6, 6, 6, 6, and 6. Okay, so if I took you to the 10th power, something to the 10th power, all the degree of each term should always add up to 10. And you would start with a to the 10th, a to the 9th, b to the first, a to the eighth, b, and you would just have to do your Pascal's triangle down to that level. There's a pattern. Math has a lot of patterns. This pattern is to help you if you encounter those kind of problems to be able to solve them quickly. Because if I gave you a plus, if I say I gave you 2x plus 6 to the 5th power. Well, think, when I just went to the 3rd power, that was like a 2 or 3 step problem. Every time I do a power, I'd have to FOIL it. Then I have to FOIL it again and FOIL it again. I have to keep, every time, each level would need its new box. So we'd have to do the first binomial, then multiply by the 2nd binomial, then the 3rd binomial, then the 4th binomial, and the 5th binomial. Each binomial would have to be done separately, but if I know this pattern, I can solve it very quickly. I know it's 6 times the first term times the 2nd term. Yes, sir.
Is this supposed to be a 1 right there at the second to last AB?
Where are you looking? I am not putting any numbers in. I didn't put the numbers in. I just gave you the letter progression.
No, I'm talking about the second to last AB only has a 5.
Where are you looking?
Right there, the AB.
Well, it's a to the first, b to the 5th. This is b to the 6th power, right?
Yeah.
It's 6. There, just like we have a to the 6th. This is really a to the 6th, b to the 0. A to the 6, but since anything to the 0 power is 1, we don't put it down. But that's what is actually occurring there. You have to think in the back of your head, that's one end is b to the 0, the other end is a to the 0. Remember, they have to add up to, in this case, 6. At either end is always a to the 6th. One end would be 2 to the 5th, x to the 5th. The other end would be 6 to the 5th, and then there'd be a bunch of stuff in between. Or is 32. So it'd be 32x to the 5th, and so on. All right, questions? We'll put it up. Your homework. So classwork today is actually section 6.5 practice. It's back to section 6.5. It's like stuff you did last night. Factoring. So number 21 through 33 by 3. It shouldn't take you very long. In fact, you should get that all done. I have to factor out some things. You're using all the rules now. All the different rules. There could be things that are perfect squares. There could be things, the difference of squares. Things you're going to have to factor out, fully factor. So there's a whole bunch of different kind of problems in that section. Because next time, we're going to start doing equations. Let me check. Last time I assigned, you did do 16 through 40. Oh, but you did even some of the evens. How about this? Since you did the evens, change it to odd. So do odds. You assigned the evens, so now I'll just do odds. And as far as the other part, 35 through 45, odd, like that. Because you were assigned the evens before. All right? So, like I said, the classwork part you should be able to get done here in class. Homework part, you should probably get started on that. Also, don't forget correcting your tests, correcting your quizzes.